Hello and welcome to Apex Math. Today we are going to talk about understanding box plots. They're also called box and whisker plots, and we're also going to look at how to create one ourselves. The level at which I'm doing box plot is generally a middle school level, since we will be looking at really interpreting them and comparing them, and a lot of the type of questions that you'll see teachers and SATs ask you and expect you to be able to answer about these types of graphs. So let's get started. All right, so the first thing we'll do is we'll look at how do we create one. Well, let's take a data set. 4, 5, 5, 6, 7, 8, 8, 9, 9, and 10. So let's say this is our data set. Well, when creating a box plot or box and whisker plot, you want to do what's called the 5-point summary. That's how you graph it. 5-point summary. The 5-point summary is, think of it as like a dollar bill and money. So here we're at the end, we have $0. Here we're at the end, we have $1. And now if you look at using quarters or 25-cent pieces to represent the rest of our money, we know that one 25-cent piece is 1 quarter, and two 50-cent pieces, or sorry, two 25-cent pieces equals 50 cents, which is 1/2 of a dollar. And then if we went and we took all 3 quarters, we'd have 3 quarters, and that would be 75 cents of our dollar. So here is the middle of our dollar, and that's at 50 cents. And halfway between 50 cents and 0 is a quarter, or 25 cents. And halfway between 50 and a dollar is 75 cents. So with box plots, instead of being money now, we're looking at these being percentiles. So this is the 25th percentile, the 50th percentile, and the 75th percentile. And we call the 25th percentile Q1. And notice kind of what we called it here. We called it 1Q, 1 quarter. Well, here we're just calling it Q1 instead of 1Q. The 50% mark is the middle. And we know we have a special name in math for the middle, and that's called the median. So that spot there at the 50 percentile mark is the median. And then our third quarter here, when we have 3 quarters, it's 75%. And because it's the third quarter, like we mentioned, we call that Q3. So the different places that we have that we want to find in this 5-point summary is the min, which is essentially our 0 percentile, our lowest value. Then we want Q1, which is our 25th percentile. We want our median, which is our 50th percentile. We want Q3, which is our 75th percentile. And then finally, we want our maximum, which is the $1 or the 100th percentile. So now we need to compute each of these values using our data set above. So the minimum is the smallest, so that one's easy to plug in. So let's plug that in with a 4. And our maximum is 10. That's our highest value down here. And you know how to find a median. Probably learned that before you've learned box plots. And you order the numbers from smallest to largest, which we've already done, and we cross off the highest and the lowest one pair at a time until we get to the middle one or two numbers. And in this case, because we have an even set, we have our middle is at two numbers. So in order to find the exact middle, we want right between these two numbers, right between 7 and 8. So if you think about it on a number line, that is the value 7.5, falls exactly halfway between 7 and 8. Another way that you could have done it, let's get this out of the way, is you could find the average. If it's not something that you can just look at and get the answer to, then you can take the average of those two middle numbers, and that will give you your median. So I could have done 7 plus 8, the two values, divided by 2. That's 15 over 2, which is equal to 7.5. So either way, either intuitively or using the average or mean formula if you have two middle numbers. All right, so now we have our median. So now we need to find this Q1 and Q3. Well, Q1 becomes the median between 0 and the 50% mark. So I simply have to find the median again, but instead of finding the median of the whole data set, I'm finding the median of everything to the left of this line here. So I'm going to find the median of these data values. So I'm going to cross off a high and a low pair, and this time I'll do it in blue. So I'm going to cross the 4 off with the 7, the 5 off with the 6, and the middle number that would be left on that side is a 5. So that becomes my Q1. Now I find the median on this side, the median of the second half. So I'm going to cross the 8 off with the 10, the second 8 off with the 9, and that leaves this 9 as the middle of the second set of numbers. So that becomes my 5-point summary. So I'm going to write that over to the side here so that we can open up some space for our box plot. So we have 4, 5, 7.5, 9, and 10. Now we're ready to create our box plot. So our box and whisker plot, it's called that because it has a box in the middle and two lines on the side, which are referred to as the whiskers. So what I need to do is I need to make an axis. And my axis needs to run from my minimum to my maximum, and it needs to go by a set value. I'm going to make it go by ones. If you've got a large spread here, you can go by 2s, by 10s, by 100s, whatever you need to, as long as it's the same number between your tick marks. So I'm going by a value of 1. A scale is another way to refer to it. 8, 9, 10. And this is whatever my data is. This is number of raisins in a box or whatever, you would put that data name down there. Now, to graph the plot, what I always say is to put a dot on each of these values first. So I'm going to put a dot up here at 4, a dot at 5, a dot at 7.5, a dot at 9, and a dot at 10. Now, the first and last two dots you're going to connect with lines. Those are your whiskers. Your middle dots are going to be connected with a box, a rectangle. It's going to go down, connect to these whiskers. The dot in the middle also gets its own line. So you should have a whisker, a box, another box, and another whisker. Sometimes, if these two numbers are the same, your whisker may shrink down and push on top of itself so you don't have a whisker, or your box may be shrunk down and so you don't have this extra box. So that can happen when these numbers are identical. When your min is the same as your Q1 or your Q1 is the same as your median, then sometimes you won't have a whisker, a box, and a whisker. So that is how we draw it. Now let's talk about the more important part, which is how do we interpret and make sense of it? Well, each piece, and there's 4 pieces here, and remember this is how it was created, represents 25% of the data. So 25% of the data fell between 4 and 5. Another 25% of the data fell between 5 and 7.5. So you can see there was more, the data in this second area was more spread out because it's the same amount of data, it's still 25%, but we go from a distance of 5 to 7.5. So therefore it has to be more spread out. Then we have 7.5 to 9, that represents another 25% of the data. And then the last is from 9 to 10, represents the last 25% of the data. Let's talk about it with a real world example, and that will help make more sense. So let's take a look at some class grades and pretend we have 2 different classes. This was students from class A and students from class B. And I'm going to make my scale go by tens, 50, 60, 70, 80, 90, and 100. And my first plot is going to start here at 55, and then it's going to go with my second dot is going to go at 80, and then at 85, and then at 90, and then at 95. So that's my 5-point summary. So I'm going to connect and make my box plot for class A. Now for class B, I'll use a different color. My first dot, my minimum, is going to be up here at 70, and then at 75 is going to be my next dot, and then at 80 is my next one, and at 85 is my next one, and then at 100 is my last one. So I'm going to connect these. And my question to you to start is, which class do you think did better? If you had to be in one of these 2 classes, and these were your grades from 50 to 100, which class would you rather have been a student in, class A or class B? So press pause for a minute and take a look at these box plots and come up with your answer before you turn it back on, and then we'll talk about it and we'll see if you were right or if you want to change your mind. So these are grades down here, and let's talk about interpreting this. So 25% of the class in class A, 25% scored between a 55 and an 85. An 80. So 25% of the class, a quarter of the class, got between a 55 and an 80. Then we have 25% here. This box is another 25. And that 25% scored between an 80 and an 85. And then this 25% scored between an 85 and a 90. And then the last 25% scored between a 90 and a 95. Now let's look at the other class. So the other class, the lowest grade here was a 70. 25% of the class scored between a 70 and a 75. Another 25% scored from 75 to 80. Another 25% scored from 80 to 85. Put that over here. 25%, 80 to 85. And then the last 25% scored from 85 to 100. So, which class would you rather be in? Well, certainly the students in Class B got higher grades overall because they scored higher and their lowest grade was not as bad as the lowest grade in Class A. So that might be a reason to say Class B looks better. And you say, well, I might be in that top 25% that scored between 85 and 100. But if you look at the second graph, what percent scored at that same range from 85 to, it's not 100, but to 95. So 85 to 95 in this class, if we look, well, here's our 85, and that's supposed to line up with this median here. So we have from the 50% mark all the way to the end. So that's 50% of the class. Half the class got an 85 or above in Class A, while only 25% of the class got an 85 or above in Class B. So you have a much better chance of having gotten an 85 or above if you were in Class A than you would have in Class B. Also, if you look, if we look at the 75% mark, the students in Class A, 75% of the students got an 80 or above. And depending on what school system you're in and how they grade, I still like to think of an 80 as a B. So that's an A or a B. While in Class B, if we look at the 75% mark, that's here. The 75% mark is students only got from 75 to 100. So they have that extra group that scored lower down here. Now we certainly have this tail where we have 25% of the students here that scored below the B. And on this graph, we only have 25% of the students scoring below a C, below a 75. But they stopped at a 70. So your lowest grade you could get in Class B is a 70, while the lowest grade you could get in Class A would be a 55. But remember that this only represents 25% of the class. So the same number of students here as there are here, here, and here. And that's where students get confused sometimes, is they forget that each piece of this box and whisker plot represents the same amount of data. The same number of students is represented in each of these ranges. So you could argue it both ways, but personally, I like the idea of the fact that 75% of the students got an 80 or above, and that I'm going to have an A or a B or an 80 or above in Class A. And I know I'm not going to be one of those 25% down here, so my choice would be to say that Class A is the class I would rather be in than in Class B. Maybe it depends on what type of student you're in. All right, so other things to think about with the box plot is long boxes and whiskers mean very spread out data. So if we look at this box plot here, we can see, we'll do some grades here again. Let's say this is a 50, this is a 70, this is a 75, this is a 98, and this is 100. So the longer your line or your box is here and here, don't mean more students. Same number of students scored in this range as scored in that range. It just means there were a whole bunch that scored right here between 70 and 75. And there were the same short group of students that scored between 98 and 100. So 25% of the class got 98 to 100 for a grade here. Same number of students here as here, even though that this is just a tiny little line. Each box represents the same number of data values. Long boxes just means the data is much more spread out. You might see 50, 55, 60, 62, 68, 70 in something like that where it's more spread out, while in the short box you're going to have the same number of students. So we've got the same number of kids, it's just our data is not as spread out. We only have 98s, could have gotten a 99 in there I guess, but 98s, 99s, and 100s. It's just the data value is much more closer together, but there's the same number of data values. So the last thing we probably should talk about is the idea of this IQR, which is often asked. Now, again, in early elementary school, you learned what the range of data was. If the lowest grade was a 50 and the highest grade was 100, then your data ranged from 50 to 100. You subtract the two, and that gives you the numerical value 50, which is the range of data. The IQR is the range of the middle 50%. The range of the middle 50%. So if we have a bunch of data values, and here's a quarter, here's a half, here's a quarter, that kind of look more right there, then the range goes from this value to this value. That's your range. But your IQR is the smaller range. It's the range of the box only, ignoring the whiskers. This is the IQR, the range of the box in the box plot. And that is computed, actually let me just clear the screen here. The IQR is found by simply taking the same thing we did with the range, which was the max minus the min. Range is the max, the highest, minus the smallest. So the IQR is the highest value of the box, which is Q3, minus the smallest value of the box, which is Q1. So the IQR, which is the interquartile range, the range among the inner quartiles, is Q3 minus Q1. So when we had our data, what was it, like 4, 5, 7.5, 9, and 10 for that first box plot that we drew. The range would be 10 minus 4, or 6. But the inner quartile range is the difference between Q3, which is 9, minus Q1, which is 5. So the inner quartile range is 4. I hope this helps you understand not only how to graph box plots with the 5-point summary, understand the concept of each line and box, meaning 25% of the data. Each whisker and box is 25% the same number of data values, which makes when you interpret it, you have to take that into consideration. And then finally, calculating the IQR is the interquartile range, which is calculated by the range of the box. This high number here, Q3, minus the small number here. And we do not take the whiskers into consideration. We just look at the range of the box itself. The other thing that your class may or may not talk about with box plots are outliers. Outliers is when you have a data value that's really out of whack with the rest of your data. And what we usually do is we have a formula to calculate that. And if it comes out to be an outlier, then we take that data value out, recalculate the 5-point summary without the outlier, draw the box plot, and then star the outlier on the graph. To compute that, we won't go into that in this lesson, but it's any data values, numbers that are less than Q1 minus 1.5 times the IQR. And you do that first. You do 1.5 times the IQR and then do Q1 minus that number. Or numbers that are greater than Q3 plus 1.5 times the IQR. And anything that is on that outer edge would be considered an outlier as well. And I hope this lesson of Apex Math was helpful. Please like our videos, and we welcome comments on any future videos that you would like to see us create, or if there's anything in this video that you want more details of. If you want us to do a detailed video on how to compute outliers, how to graph box plots without outliers, we're happy to do it. Just let us know in the comment section. Thank you very much.